Welcome back, guys. So in our previous video we have solved part A, part B of our question, and the link of it will be available here. Now let us solve part C, D and E of our question. So let me first remove all of this. So in part C, the normal curve area between x equal to 32 and x equal to 41. So this is part C and this is x equal to 32 and x equal to 41. What do we have to do? We have to convert them both into the z value. So z would be equal to x minus mu divided by sigma. So the value of z is x minus mu divided by sigma, where mu is the mean, sigma is the standard deviation, as we have studied in our previous video. So therefore let me apply it here. So it would be 32 minus mu, which is 30. Okay, 30 divided by the sigma, this sigma, which is 6. Okay, so it is here, and this is, let me call it z1, and let me call it x1, this is x2. So the value of z1 would be equal to 2 divided by 6, which is 1 by 3. So 1 by 3 is 0.34. Okay, similarly for x2, this is, let me have here z2, it would be 41 minus 30 divided by 6. Okay, so the value of z2 would be 41 minus 30 is 11 by 6. So 11 by 6 is what? This is 11 divided by 6. Okay, this is 1.84. 1.84. So these are the two value of z, and we have to find out the area in between them. Okay, so if we want to find out the probability that z is greater than 0.34 and less than or equal to 1.84, how to find it out? We know that it is probability that z is less than or equal to 1.84 minus the probability that z is less than or equal to what? 0.34. Okay, so these are the two values, and we have to find them out by using the z distribution table. This is basically z2, this is basically z1, and let me consult our table for 1.84 and 0.34. so for 1.84, let me move to the 1.8, this is 1.8, and for 4 the column is this one. Okay, so 1.84 is 0.967. so 0.967 minus the probability that z is less than or equal to 0.34. so 0.34 is, this is 0.3 and 4 is this one, so this is the value 0.633. so 0.633. okay, let me calculate it. So it would be what? 0.967 minus 0.633, it is 0.334. 0.334, and that is basically the solution of part C of my question. Okay, in many books you would see that this answer is different than those, because I have approximated 3 repeating 3's as 4's and repeating 3's as 4's here as well. So therefore there is a difference. If you will calculate it like 0.33 and 1.83, it will be the similar one as given in those solutions, but this one is for the repetitive values of 3, which I have estimated as 4. Okay, so that is the solution. Part D of our question is what? The value of x. We have to find the value of x that has 80% of the normal curve area to the left. Okay, so let us have this normal curve. Okay, and let us have here the value where almost 80% of it is at the left, and it is also known that this is a normal curve. So as the overall area is known and we have been using the z distribution here, so therefore we know that according to the z distribution, x is less than or equal to z, that value is given and that is 80%. So let me call it 0.80. okay, so this is known because all of these values are on the left side, and this is the value which we can use in the z distribution table. Similarly, in order to find the value of z, which is here, okay, let me use another color. In order to find out this value, what do we have to do? We have to find the inverse of 0.80, means in the table we have to look for the value of 0.80 and the corresponding value of z will be our answer. Okay, so let us consult the table, and here let us find the value 0.80 or the nearest one. Okay, so let me have here, so 0.80, let me have it. So this is the nearest value, 0.799, which is around 0.80, and the value it has is, the corresponding value is 0.8 in the row, and in the column we have 0.04. so 0.04, adding them together we will get 0.84. okay, so the value of z is 0.84. so the value of z is known. Now in order to find the value of x, what do we have to do? In order to find the value of x here, we know that previously we have calculated the value of z from our value of x was x minus mu divided by sigma. So on the basis of it, we can use the value of x is mu plus z multiplied by sigma. Okay, so we know the value of mu, we know the value of sigma. Let us put those values here. So x is here, 30 is mu. Okay, the value of z is here 0.84, multiplying it with sigma, which is 6. Okay, so it is here we have, let us calculate it. So it would be 0.84 multiplied by 6, so it would be 5.04 plus 30, so 35.04. that is the value of x and the answer of part D of our question. Now let us proceed to part E. The two values of x that contains the middle of 75% of the normal curve area. Okay, so let us first remove it. Okay, so this is part E, and let me use the similar procedure what we have used in a previous question was this. Okay, and let me have here this x, let me call them z and minus z, and the area here is what? The area in between them is this one, and this is around 75%. This area is 75%, means the overall area here was basically what? This was the remaining 25%, means this is what plus this one. Let me call this one A, this one B. So this A plus this B, this is the remaining 25%, means what are those areas? This area is the what? This one is the probability that x is less than or equal to minus z, plus this B is here the probability that x is greater or equal to z. This is the 25%. Okay, similarly, as this is a symmetrical curve, therefore each area here would be what? It would be 12.5%, and this is also 12.5%. Okay, so this is it, half of the 25%. So suppose here if I want to use this value, because this is the negative of it, if I want to use this value, what can I use? I can use all the values which are less than this. So therefore, in order to use this value, let me use this black color. So here it will contain what? It will contain this area plus this area. as well. So therefore the probability that x is less than or equal to z, that is equal to the probability that this one and this one and this one is basically 75% plus the remaining this 12.5%, so it would be 87.5%, which is what in terms of probability it would be what it would be. This is 0.75 plus 0.125, so it would be 0.875. okay, so this is what we have here, and this is the probability that x is less than or equal to z for this z. Now in order to proceed, let me use this color. In order to proceed here, we want to find the value of z, which is here. So this z is the inverse of 0.875. okay, let me use the table here to find the value of it, which corresponds with the z value. So let me use the table, and here let me search for 0.87. so 0.875. okay, this is the 0.875. okay, so it is 1.1 in the row, and in the column, what is it? It is 5, so 0.05, so it is 1.15. so the value of z is 1.15. this is the value of z, and similarly the value of minus z would be minus 1.15. so these are the two values which are here. So this is minus 1.15 and this is 1.15. in order to find the value of x from them, we have the formula, and that is the z equal to x minus mu divided by what? Divided by sigma. okay, so now in order to find the value of x from it, it was what? It was mu plus sigma z. okay, this is what we have found in our previous question. So now here the value of x1 would be, the value of mu is given, that is 30, plus the value of z is 1.15 multiplied by what? Multiplied by 6. okay, this is for x1. so the value of x1 would be what? It would be 1.15 multiplied by 6. so this is 6.9 plus 30 is 36.9. this is for x1, and for x2 we have here what? Let me move down somehow. For x2 we have here 30 plus value of z is now minus 1.15, and multiplying here with this 6, which is sigma. so this would be 30 minus 6.9. so this would be x2, and the value of x2 is 30 minus 6.9. this is 23.1. so 23.1, and that is the value of x2. okay, means in the distribution where this is now 30 and the standard deviation is 6, this is x2, this is x1. so it is 23.1 and this one is 36.9, and it basically holds this area, which is almost 75% of the total area. So you have found this answer from the procedure we have followed here. okay, so that's it for today, in which we have seen the remaining parts of question 6.8. if you have any question, you can ask me in the comment box. See you soon.